This is Quick Clip 2.07, Design of the Periodic Table. When we look at the periodic table, we see that the elements are organized by atomic number going from left to right. So when we look in the upper left-hand corner, we see hydrogen with 1, and then moving across to the right, we see helium, and then the next column starts, we have lithium with 3, beryllium with 4, boron with 5, and so on. These horizontal rows are called periods, and again, they increase in number going from left to right. Now, before we talk any more about the periodic table, we need to learn a little bit about valence electrons. Valence electrons are the outermost electrons of an atom. In our example here, we have beryllium, and you can see that it has a total of 4 electrons, but it has 2 in its outer shell. These are its valence electrons. They're important because it helps tell the element or tell us how the element is going to react with other elements. So these valence electrons are very important. They kind of dictate how they are going to chemically react. When we look at the periodic table, the table can tell us how many valence electrons there are for different elements just by looking at how the columns are numbered. Not the rows, but the columns going up and down. So here we have column 1, column 2, column 3 through 12 we're not going to consider. These are the transition metals, and we're not going to consider them in this system. And then there's column 13, and if you look at the number 13 there, you can see that the 1 is in black and the red is in 3, and that's because we are only going to consider the number in the 1's column. So the 3 is important in the 13. Same thing for the 4 and 14, for the 5 and 15, and we have 16, 17, and 18. So we're going to only consider the numbers in the 1's column. Let me show you how this is going to work. So for beryllium, we have 2 electrons in the outer shell. When we find beryllium in the periodic table, we see that it is indeed in column 2. So beryllium in column 2 has 2 valence electrons. So the number of the column tells us how many valence electrons there are. So that means all of the elements underneath beryllium also have 2 valence electrons. So that makes them very similar in how they are going to react with other atoms. These are called groups or families. And the term families is very appropriate because they have their valence electrons in common with each other, and they will react very similar to one another. If an element is in column 13, it's going to have 3 valence electrons. Carbon in column 14 has 4 valence electrons. Oxygen in column 16 has 6 valence electrons, and so on. Next, we speak about the octet rule. Now, the octet rule refers to the tendency for all atoms to want to have a full outer shell. So if an atom had 7 electrons in the outer shell, it wants to get that 8th atom to fill its shell. In our example here, we have an atom of neon. It has 10 protons, and if you notice, I've taken away the neutrons just because it would get too crowded. And it also has 10 electrons. It has 2 in the first shell, and the first shell is so small that it can only have 2. It's filled when it only has 2. But the shells outside of that first one will carry 8. So it has 2 in the first shell, has 8 in the second shell, and its outer shell is full. And so all the other atoms on the periodic table want to have this same stable situation where their outer shell is full of electrons. When we look at the periodic table, we indeed do have column 18, right? And that 8 tells us that every one of those elements in that group has a full outer shell of 8, with the exception of helium that has a full outer shell of 2. And again, the octet rule says that all of these other atoms would like to be like these special elements because they have a full outer shell. They are so special, it has a special name. This group of elements are called the noble gases. because they have a full outer shell, and all atoms want to have a full outer shell just like them. So to review, we have horizontal rows that are called periods that increase from left to right. We have groups or families of columns that have the same valence electrons and react in a similar way. We can determine the number of valence electrons by the group number. And we have a special group, group 18, that are called the noble gases that have full outer shells of electrons.